All right, here's one last example that we'll be doing. And this one is looking strangely similar to example 1.7 that we did. And we are definitely going to use that information to help us solve this. So suppose that for any epsilon greater than 0, we have a minus epsilon is less than b, which is less than a plus epsilon. Another way to look at that is b is between a minus epsilon and a plus epsilon. We have to prove that a is equal to b. So again, recall that if we need to prove equality and we have inequalities, we're probably going to have to prove that a is greater than or equal to b, and a is less than or equal to b. And we could sandwich those together, right? So we would have a is less than or equal to b, which is less than or equal to a. If we have an inequality like this, if b is between a and a, right, then that means b must equal a. That's kind of the idea here. So we're going to need to do something in that sort of fashion. So I'm immediately going to be thinking of example 1.7, and we can use this since we've proved it. So remember, we proved, so we'll say recall for any, if we have any epsilon greater than 0, if a is less than b plus epsilon, then we'll just say that this implies that a is less than or equal to b. So it looks very similar to this, it just looks like it's on both sides, but it's nothing too bad. What I'm going to do is kind of just look at the right side of that really large inequality for a second. So I'm going to look at this right here. And this is pretty much in the same form. It's just the a and b are flipped, and that doesn't matter. It'll just flip the a and b in our result. So we can start our proof here. And so we can say by example 1.7, since we have b is less than a plus epsilon, we know. So let's look at this for a second. If we have something in this form, that means that a is less than or equal to b. So it'll be this over here is less than or equal to this number. So we're going to say, okay, this will be less than or equal to this number. So we know that b is less than or equal to a. Okay, so we're halfway there. Now we need to somehow get it the other way. Well, what I'm thinking of now is maybe we can look at this part over here. A minus epsilon is less than b. And maybe we can move the epsilon over and move that b over, or I don't know, something, or keep the b over there, just move the epsilon over. And we'll get it in another similar form. So also consider the fact that a minus epsilon is less than b. So how can we move the epsilon over? Right, because we want it to be a plus epsilon. We don't want the minus epsilon, so that's why I'm thinking of moving it somewhere else. So what we can do is use our axioms. It'll be axiom 2 to add epsilon to both sides. So by axiom 2, add epsilon. So we have a minus epsilon is less than b. And what we can do is add epsilon to both sides. And what we get is we get a is less than b plus epsilon. And now we can use this rule that we have. And in fact, it's in the exact same form. So we can say, with this information, we know that A is less than or equal to B. Thus, we have the following. So we have A is less than or equal to B. That was, I'll put it in green, make it very obvious. We have this fact, and we also have this fact. So we know that A is less than or equal to B, and B is less than or equal to A. And we can just chain these together. So A is less than or equal to B, and B is less than or equal to A, so we can say that. And if B is between A and A, they must be equal. So therefore, A equals B. And that is it for that proof. So just to reiterate, we had for any epsilon greater than 0, we have this nasty looking inequality, and we had to prove that A is equal to B. And it looks strangely similar to this fact that we proved in example 1.7. So my goal or my thought process was to just use and get it in the form of example 1.7 and use that information. Once we prove something, you want to use it to your advantage. Okay, you want to make your life a bit easier, right? Mathematicians are lazy. So I'm not going to rederive this again. I'm going to use what I know. So with this example, I got my stuff in this form, and with that I can deduce a new inequality, and then I can chain them together by axiom 1. So this was by axiom 1. So again, the axioms come in very handy when we're doing our proofs. And that will be it for the exercises. We will, for the next lecture, we'll be looking at some roots. So that's what we'll be doing.